For our tolerancing scenario, we analyze this connector and socket that is used for a USB-C adapter. Connector and socket geometry typically include a male and female part, with the male part designed to fit into the female part. The size tolerances will define the allowable limit in the size of the connector pins and the socket holes. Positional tolerances will also be applied to the location of the pins and holes to ensure they align correctly.
This is our drawing for the male socket of our assembly. Starting in the upper right with a side view of the part, we establish our first datum A to take away 2 degrees of freedom on the very back side of the part with a flatness relation and tolerance zone of 0.01 inches. Furthermore, the part is stepped twice to larger thicknesses of 0.1309 and 0.1737 inches, respectively. Both of these dimensions are perpendicular to datum A with a 0.01 inch tolerance zone and maximum material condition. Datum B is established on a flat profile sectioned out of a cylinder with a 0.01 inch tolerance zone to prevent rotation and remove another degree of freedom. Because this part is symmetrical, the side opposite datum B is parallel and also has a 0.01 inch tolerance zone. The overall length of the part is 1.2459 inches. Moving on to the top view of the part, we establish a datum C along the left edge of the part. The rectangular portion above the body, which datum C is tangent to, is 0.09 inches tall and exhibits a parallel relationship with datum C, as well as a 0.01 inch tolerance zone with maximum material condition. Despite not being critical to our mating feature, the male micro USB at the end of the socket has a length of 0.2559 inches and a width of 0.2717 inches. The long edge has a parallel relation to datum C, while the width has a perpendicular relation to the same said datum, both with a 0.01 inch tolerance zone. These relations are necessary as this USB has to be square in order to fit into a female micro USB. From the front view of the male socket, we can establish a fourth datum, datum D, which has references to datums A, B, and C and lines up with one of the prongs that mates with the female connector and forms a connection that electricity can pass through. Since this dimension has to be precise, we chose a tight overall tolerance of 5 thousandths of an inch as well as a position relation and 2 thousandths of an inch of tolerance zone size. The least material condition for the prongs is important so that the prongs are manufactured to the smallest diameter within the specified tolerance limit to ensure a fit with the female connector. Last but not least, the flat spot preventing unnecessary rotation and torque on the prongs and the inner radius has unilateral tolerances. Similar to the least material condition, these have to be made to spec or slightly bigger since the female connector has to fit inside.
I will be discussing the female connector, which is meant to mate with the male socket. To establish the appropriate datum reference frames for our particular part, we first began by analyzing its side view and determined that the best location for datum A would be against the back flat end of the part. From here, we added our secondary datum feature to add a tolerance to the profile of the surface. This is applied to the left end of the piece from which the connecting feature will extrude. The housing on the connector is 1.1 inches long and is not a crucial dimension since the housing can be longer on one end and not affect the mating pairs. Our second datum reference frame B is found here in the bottom left corner of the drawing and is located directly along the side outer diameter of the connector. There is a secondary datum feature assigned to B that accounts for the 9 degrees of angularity created from a loft feature. On the very top of this view is our tertiary datum feature, which represents a tolerancing applied to the end of the connector. Since the extruded portion is what is being mated, it is important to apply a tight tolerance of plus or minus 5 thousandths of an inch. Lastly, this final view shows the radius of the female connecting feature as well as the 2 holes that will mate with the metal prongs located on the male socket to make the electrical connection. To establish our C datum reference frame, we applied another profiling dimension to the tolerance of the extruded connector. Note that the C datum incorporates the reference frames A and B. With datum C now fixed, we can label the 2 holes as positions to establish the fourth datum reference frame D, which will now be associated with reference frames A, B, and C. The 2 holes have an overall diameter of 0.055 inches with a tolerance of plus or minus 5 thousandths of an inch and a total depth of 0.2650 inches. We chose to apply a position tolerance that calls for max material conditions. This will ensure the best fit. Since the alignment of the holes and the prongs are essential for the mechanism to work, another tight tolerance of 5 thousandths of an inch is applied to the line located in the datum reference frame C and in the center of the 2 holes' diameters.
Thank you for watching our tolerancing scenario video. Hope you all have a wonderful summer.